In this video, I'm going to show you how to create a Huffman tree so that we will be able to do compression using Huffman coding. So in this example, we are going to compress the string called an easy example. So for that, I have already created a frequency character table. What we are going to look over here is create a table in which every character is being recognized and that character's frequency is recorded. So for example, we have A. So look how many times A is coming over here. 1, 2, and 3. So that's why the frequency is recorded as 3. So on we will complete this frequency table and then begin the process to make a Huffman tree. So when you have to make a Huffman tree, you have to firstly order all the characters in ascending order from left to right. So when we will be having, let's say, L, which is having a value 1, so we are going to write like this. Then there is another 1M with the same value, and so on. So we will keep recording them in the ascending order until we have finished all the characters that are present in the table. So the final output for writing everything in the ascending order would look like something like this. 3 would be A and another 3 would be E. So this is how your first step will look like. Now what we have to do is keep on adding the weights of the nodes which are on the left side and shift them towards the right hand side. So we will add L and M and put next to Y, then add NMP again, we'll put on next to the Y, and so on. So I'm going to show you how it looks after doing addition of all the basic nodes which are with the one node, okay, with the weight 1. Let's have a look. So once we have added all the single ones and made weight 2, y remains alone over here with the weight 1. So now what we are going to do is we are going to add it along with this 2 and then shift these together. So whenever you are going to do the addition, it should be done with the adjacent nodes which are on the left side. So do the addition of these two and put them next to A over here. So the next step would look like, so this is how the next step will look like. We have already shifted the 3 which was created from addition of SX, like the 2 weight and 1 weight. Now again the addition of these 2 bits will happen. The weight, final weight would be coming 4, so it would be placed over here. Then the addition of these 2 bits would be done. The weight would be coming 5, so it will even further shifted next to the 4 node. So I'm going to show how it is going to look in the next step. So this is how the next step will look like. Now we have one node for 4, one node for 5, and 2 separate nodes for 3. So we are going to add these together to make 6 and shift over here. And then in the next step, again we will add the node 4 and 5 to make it 9. So I'm going to skip 2 steps and I'm going to show you how it will look just before the last final step. Now as you can see, it looks like 6 and 9, and then in the one more final step, what we will be doing is simply going to join these together to make the final digit, so that you will have final number of weight available over here. So I'm going to draw a final tree, final Huffman tree that we will be using for compression. So this is how the final Huffman tree is going to look. So when you have to look for the higher weights, it will be available easily. So now we will try to look at, like we'll try to find out what is the value for a. So when you have to find out any value, you have to give numbers. On left hand side you have to number it as 0, and on the right hand side 1. So again, when you are going to have 6, here you will have 0 and 1, and then when you have to calculate the value of a is going to be 0 0. So it's that. When you have to calculate the value of e, you have to keep tracing until you find the final node. So for e it's going to be 0 1, and so on. So when you, let's say you have to find out the value of s over here, you'll be giving values like 1 0 1 0 1 0 1 0 1. So the value for s is going to look like 1 from here, then another one from this branch, then another one from this branch, then 0 from this branch because it's coming to this side over here, that's the 0, and the final 0. So the value for s is going to look like this. I hope this is clear. Hope you have understood. I'll explain further in the next video how you can calculate a value of any one digit once you have a Huffman tree with you.